And welcome to High School Physics Explained. Today I'm going to give you a quick video on how a speaker works and how it employs the motor effect. So let's get started. So here is a diagram from a speaker and there's a section that's been cut away. So let's first of all label some important parts so that we're aware of the various parts that we need to discuss. The first thing you need to understand is that we have two magnets. We have a magnet inside here and a magnet outside here. And so we have a magnet, and in this case we're going to have our magnet here that is going to be our north pole over here, and it's a circular magnet. Within the cone over here we also have another magnet, and its outside surface will be a south, which basically means that the magnetic field lines of course are going to radiate inwards. The second thing you need to understand is that we have a coil here, and that coil will be connected up to an external power supply in which we can apply a potential difference and therefore a current. Then we also over here have the suspension. Now all the suspension does, it actually supports all of this but allows it to freely move up and down, and that'll become important in a moment. And lastly we have here what we call the diaphragm. And the diaphragm again will be important when we see how all this works. So let's have a closer look in terms of the physics. So here is our diagram again, and now I'm just looking at a two-dimensional image in terms of my outside magnet, which I told you is going to be our north pole over here, and my internal magnet, which is going to be my south pole over here. And so over here we have that the grey circle is our coil. And the important thing to note, first of all, is that we now will generate magnetic field lines that are going to be radiating inward, because north to south is the direction that magnetic field lines go. Now, what will happen if I put in a current in this loop? Now, if I were to put a current in this direction over here, what will be the direction of the movement of the coil? Well, if you use your right-hand palm rule, you can work that out. As far as this is concerned, that direction of current will cause a force to be exerted, in this case, downwards. However, what if we were to change the direction of the current? And I'll choose a different color here. So imagine, for example, I have the current going in the opposite direction. What would the force therefore be? Well, again, the same rules apply, but in this case, if the current is going in that direction, the force is going to be upward. So you can see, depending on the direction of the current that we put in the coil, will determine the direction of the motion of this coil. So now let's examine this from another perspective again. So here I have my coil and I have my magnets. You can see it forms this cutaway E shape, but really what it is two cylinders. So we've got an open cylinder, which is basically our outside magnet, and our inside magnet. And for simplicity's sake, of course, we have again our north pole over here and our south pole over here. And of course, the magnetic field lines will radiate inwards like so. Now, the important thing is that if I put in a current like so, and I put in a single directional current, a DC current, then the coil, as I've described, will only move one way. However, if I were to, instead of connecting this to a DC supply, but instead I connect it to an AC supply, what's going to happen? Well, this is going to go up and down, and it's going to vibrate backwards and forwards, and it's going to vibrate at a particular frequency that is determined by my supply. Now, if this was connected to, let's say, an ordinary power pack that's found at school, so let's say connected to a 50 Hertz supply from your power supply, then this is going to vibrate at 50 times a second. But of course, what stereos do is put quite complex alternating supplies to make this vibrate in a way that hopefully will generate sound. But how do we generate sound? Well, we need to connect our cone. And our cone, of course, will be attached to the coil, and of course it will vibrate as well. So now what we have is our cone will vibrate up and down, which means this area up here is going to be pushing air up. The diaphragm over here is going to be pushing air up like so. As a result, we'll produce compression waves. But of course, we now also know this as a longitudinal wave. But of course, that is a sound wave. In essence, what we have here is the motor effect being employed. That is, a current-bearing wire is experiencing a force in a magnetic field. The current is alternating. It causes the whole cone to vibrate, and thereby converting this electrical energy into sound energy or kinetic energy, producing sound. Now, the frequency will determine the pitch of the sound you hear, and obviously the amplitude of the alternating supply will determine the amplitude and therefore the loudness of the sound that you produced. So that, in essence, is how a speaker works and how it employs the motor effect. Hope that helps. Thanks for listening and watching. Bye for now. I hope you found that video useful. And remember, like, share and subscribe. Oh, and if you have a comment or a question, or you'd like a concept for me to explain to you, please drop a comment down below. I'm Paul from High School Physics Explained. Bye for now.